Exercise 2, Binomial Distribution. On cell B6, invoke the Define Distribution icon in order to retrieve the palette window. Over the Common or Discrete tab, select the Binomial Distribution. Click on the Parameters window 3-dot icon. Then click to specify cell references in order to retrieve the two respective parameters required for a binomial, n and p. Select the range B7, B8 to simultaneously select both required parameters. Make a reference to B7 for n equal 10 trucks and B8 equals 10% probability of damage for each one of them, and then click OK to return to your distribution definition chart. At this point, the chart should look like this. At this point, this function counts the number of trucks that probabilistically would become damaged. By shifting the vertical delimiters between the number bars, you will be able to interpret different probable results. For example, drag your first vertical delimiter between the 0 and the 1, and the second delimiter between the 1 and the 2. There is close to a 35% probability that no truck, 0, will get damaged, given the fact that there's 10 on the list and that the individual probability of each one of them being damaged is of 10%. Also, there is close to a 39% probability that exactly one truck will get damaged, given the fact that there is 10 on the list and that the individual probability of each one of them being damaged is of 10%. There is close to a 26% probability that either 2, 3, or more trucks will get damaged, given the fact that there is 10 on the list and that the individual probability of each one of them being damaged is of 10%. It can be demonstrated that this binomial distribution, n equals 10 and p equals 10%, works exactly like 10 Bernoulli distributions added together, counting the number of truck damages.